Hello everybody. The purpose of this video is to walk you through the steps to actually physically wire up our ArduinoScope. And the primary thing that we're going to be concerned with is actually connecting our trigger button to our solderless breadboard so that we can use it for future circuits that we're going to build. So you're going to want to first place your button near the end of your breadboard to leave all the room you can to build the actual circuits that you're going to build later. So the button that we're going to place down today looks something like this. If we look at the bottom, it actually has 4 leads, and so we're going to want to straddle those leads across this center portion of our breadboard. Remember that the row A1 through E1 is all connected internally on the breadboard, and F1 through J1 is all connected internally on the breadboard. But this interior barrier here is not conductive. So anything that we put across that straddles across this middle of the breadboard is not electrically connected. Okay? So I'm going to place down the button now, and you want to be careful when you're placing your button that you line up the holes with the feet of the button, and you want to be careful not to bend the feet when you're pressing it in. And so don't be too harsh, but don't be too gentle either. You have to press it into the slots. And when it's in, it should look something along the lines of this. And so now the top of our button is connected along the first row, and the bottom of our button is connected along row 3. All right? All right, so the next thing that we're going to want to do is connect the top left of our button to our power rail. So I'm going to use a red wire to do that. So I'm just going to plug this in from pin A1 over to the positive power rail, like so. Okay? And then the next thing we're going to want to connect is our 10 kilo ohm resistor. And I just realized that I made a mistake in the video that I did the circuit diagram and made the 10 kilo ohm resistor a 220 ohm resistor. But we're using a 10 kilo ohm resistor today, and I may edit that back into the other video. But we want to place this now on the bottom left of our button. So we want to go to the third row and then bring that down to where it's comfortable to place the resistor into the circuit board with the other end. Something along these lines. And so now one end of the resistor is plugged into C3, and then the other end of the resistor is plugged into C8. Okay? And so now, following along with the diagram, we want to connect the other end of the resistor that's at C8 to our negative rail, or our ground rail. And so to do that, I'm just going to take a jumper and connect A8. Remember that A8 is connected to C8. And then connect A8 over to our negative rail, or our blue rail in this case. And so now, this is what our circuit looks like. So we have the button, we have A1 connected to our power rail, and then we have the bottom side of the button connected to C3, and then C3, the resistor of C3 is connected to C8, and then A8 is connected via jumper to the negative rail, or the ground rail of our circuit. Okay, so now the last thing left to connect to get our signal into our trigger signal into our Arduino is to connect the other side of our switch, so that when we press the switch, it will activate the digital I/O line DIO2. So we can go down here and find DIO2. And we'll plug this into there. Okay, and then I'm going to bring that up to J3. Okay, and so now our digital I/O line 2 is connected to the output of our button. Okay, so now if we press this button, we will send a signal to DIO2. All right, now you might be asking yourself, hold on a second, what's left to do here? We have this power rail, but we haven't actually connected it to the power or the ground of the Arduino. So that's the next thing that we need to do. So I'm going to take another red jumper, and I'm going to locate the 5-volt signal on the Arduino board. And you can see that is right here. It's a little bit difficult to see, maybe if I angle it a little bit. So you can see here is ground, ground, then 5 volts, and then 3.3 volts. So we're going to connect this to the 5-volt line, and then we're going to connect that to the other end of our circuit board to our power rail. So now we have 5 volts going to our solderless breadboard, and then the final wire that we're going to connect is our ground wire. And the ground, we need to get it right there beside the 5-volt pin. So the very pin beside the 5-volt pin is the ground wire. And then we need to run that over to our negative rail, like so. Okay, so now that is our trigger button in the circuit. So we have the power rails connected to the Arduino. And then we have the button wired to the 10 kilo ohm resistor running to ground, so it's a pull down resistor. And then the output side of the button we have connected to digital I/O line 2. Now the final thing to have a useful oscilloscope here is that we need to connect a probe or a wire to analog in A0. And then this probe, A0, will be what we will use to measure things in our circuit. Okay, so I'm going to plug a green wire into A0, which is located here. Okay, and so now this probe can be touched anywhere in our circuit that we need to measure the voltage of a signal. Okay, and so I'm going to do a quick example of this, and I'm going to bring in the signal from digital I/O line 9, which is a PWM signal, and then we'll look at that using the Arduino to look at what the output of a PWM signal looks like with various parameters set. So we locate digital I/O line 9 over here. I'm going to plug another jumper into there, and I'm just going to bring this over to our breadboard. Just pick a random spot on our breadboard that I'm going to put it in. And then I'm going to connect the green probe. Remember, this is our oscilloscope probe now. And I'm just going to plug that into the rail, or into the row beside the orange. Okay? So now at this point, what I'm doing is I'm writing out along this orange wire the PWM signal, and then I'm going to read that in on AIO line A0, so analog input line A0, and that's the green wire. Okay, so let's look at the program to generate this PWM signal, as well as the program to read from the trigger button and look at the signal that's on A0 on the oscilloscope.